Welcome to the interface. Today we are having Professor P.P. Divagaran, formerly of Tata Institute of Fundamental Research, Bombay, with us. Hello, sir.
Very pleased to be here.
You are interested. Your basic interest is in physics, and quantum mechanics,
quantum field theory.
Quantum field theory.
Yeah, my interest has always been in physics, and till I retired, I was a professional physicist. I still am, but many other interests now.
But you are also having interest in the history of mathematics.
That's something which started about 10 years ago, and the reason why it started is that I met a very, very distinguished scholar, Dr. K.V. Sharma, who has done more than anyone else to make prominent, to bring to light the extraordinary achievements of the mathematicians who lived in and worked in Kerala, not very far from here. So I met him more or less by chance in Chennai, and he said, well, you are a mathematician, you are a physicist, and you understand Malayalam, you can read Malayalam, so why did you take an interest in the mathematics of the people who lived in near the in and around Tirunavaya? So
you are interested in the history of mathematics history of the Indian mathematics mainly, but since you are from Kerala and I am also from Kerala, I am more interested in asking some questions regarding the history of mathematics in Kerala.
Yeah.
So what are the big names, or what are the main mathematicians who lived in?
Yeah. See, there are two phases to the activity, mathematical activity in Kerala. The first is represented by two names. One, the senior one was a man called Govindaswamy, and his disciple Shankara Narayanan, who worked in Kodungalur. At that time it was called Mahavadevapura.
Observatory.
He had an observatory there, and he says so, Yantra Valaya, and he also wrote a book which is of very great historical value, and that book was brought to light not by historians of mathematics but by a true historian, Elankulam Kunjan Pillai, because using the dates, astronomical dates in it, he could establish the dates of some of the emperors of the Second Chera Empire. So that was there.
It is also mentioned in the PhD thesis of Professor M.G.S. Narayanan.
Of course, because M.G.S. Narayanan was, Ilankulam was in the department of Malayalam, M.G.S. was in the department of history, but he wrote his thesis with the help and under the supervision of Ilankulam. So it's natural.
And after Govindaswamy and Shankara Narayanan, what are the main figures in Kerala?
So then for about 500 years we have no news, no mathematical news from not only Kerala but from many parts of South India, except one or two names in Karnataka. And then about 1400 there came an explosion of mathematical activity, and this is attributed to all the people who came later, to the great Madhava, and everybody who came after him.
So say something about Madhava.
Yeah, but I will say first who followed him and then what they said about Madhava, because we don't know anything, very little. We know very little about Madhava himself personally. He didn't really leave a major mathematical text behind, but his disciple Parameshwara, his son's disciple Nilakanta Somayaji, Nilakantha's disciple Jeshtadeva, his disciple Shankara Variyar, Achyuta Pisharadi, all of them wrote many books. Not many, all of them, but some of them wrote many books. Jeshtadeva has written only one book, and all of them quote the verses due to Madhava, in which extraordinarily beautiful mathematical results are explained. And so we know that the founder of the school was Madhava, that all the original, creative, truly creative, wonderfully original ideas were all attributed to Madhava. And these people all claim that we are explaining what he taught us.
This Madhava is supposed to be from Iringalakuda and from a...
I happen not to agree with that because K.V. Sharma is responsible for this particular piece of information. K.V. Sharma and K. Kunjunli Raja, who was at that time in Madras University in the 50s and 60s. And as far as I can tell, there is no good reason for it, because
in the translation, in the Vyakhyana of Venvaroha, Achyuta Pisharadi is giving some details about...
No, that's not possible, because Achyuta Pisharadi did not write on Venvaroha as far as I know. Did he write anything on Venvaroha? I don't know. What we know in Madhava's own words in Venvaroha is that he is from a house called Bakuladhishtita Vihara.
Ilanyipalli.
Then in another fragmentary manuscript, which is now in Baroda, this is all K.V. Sharma's detective work, he is referred to as Ilanyipalli Madhavan Embran, which tells us many things. First of all, Ilanyipalli and Bakuladhishtita Vihara are exactly the same, they have exactly the same meaning. It was very customary in those days to take Malayalam names, house names and village names, and turn them into Sanskrit. Like, for example, Alathiyur will become Ashwathagrama.
Kozhikode Kukkudagram.
Then similar, many other similar things they have done. So I personally think that Ilanyipalli and Bakuladhishtita Vihara refer to the house to which Madhava belonged. Then subsequently, both Parameshwara and Nilakantha referred to him as being of Sangama Grama. Now, Sangama Grama, if we accept that it is a Sanskritization of a traditional Malayalam name, in the area in which all these people worked, there was in fact a Sangama Gramam. It's called Kudalur. It is still there. So I've been there, and not only that, not very far from it, there is still an old Brahmin household called Kodallurilam. I have also been there, and so my feeling is that Sangamakarama Madhavan Embran of Ilanyipalli house is a product of this area, that is Bharatapura area, that is to say from Tirunavaya, Tripurangod, upstream up to Kodallur, and maybe a little beyond towards Patambi. And I also think that Embran identifies him as a person who came fairly recently from Tulunadu, because the Brahmins of Tulu country were called Embran or Embrandri, and that distinction apparently got fuzzy in course of time, but I personally think so. Historically it fits, because he brought a kind of new mathematics which was not known in the 500 years that passed between Shankaranarayana and Madhava.
So coming to the mathematical content of Madhava's work,
I am somewhat surprised at the fact that there is a great deal of disagreement among the scholars. Not a great deal. There is some reluctance to say exactly what it is that he did so wonderfully well. And in that story, there are many historians who have contributed, and I think some of the misunderstanding is due to the fact that the true textbook which describes Madhava's work in great detail is this text called Yukti Bhasha. It is written by Jeshtadeva, and it is in Malayalam, it's in prose. So there were very few scholars who actually could read Yukti Bhasha in Malayalam, and K.V. Sharma was an exception. Kunjunni Raja was an exception. Then in the middle of the 1940s, one of the local Rajas, Ramavarma Marutambaran, together with the modern mathematician Akhileshwara Iyer, wrote a beautiful annotated commentary
published by Mangalodayam.
And so that was not read by anyone. Certainly not the Western scholars were completely lost by that book. And K.V. Sharma, for all his greatness, did not have a feeling for the mathematics. So, the last great work of K.V. Sharma was to produce an English translation of Yukti Bhasha, part 1, the mathematical part, not the astronomical part. So, till that translation came, nobody knew about Yukti Bhasha, except a few people, except maybe half a dozen people, people interested in the subject. So, Yukti Bhasha, several places, and as important as Yukti Bhasha is also the last great work of Nilakantha, which is the Bhashya of Aryabhatiya, which is also a work in prose but in Sanskrit. But that is full of references to Madhava. In fact, many places, quite a few places, Madhava's name comes up. For example, there are places where he will say Madhava adi Ganithatnyacharya, or he Madhavodita.
That is the case with
Madhavokta.
That is the case with other people also. Parameshwaran.
Parameshwaran does not refer to Madhavas by name so many times, and these references come.
But Parameshwaran treats Madhava is the guru of.
But he was his guru.
Nice.
Parameshwara was Madhava's Shishya. Okay, whereas Nilakantha was not, and Madhava was not alive when Nilakantha became Parameshwara's, went and lived in Parameshwara's house to learn from his sons. So at that time, Damodara and Ravi both. At that time, that was, Nilakantha, Parameshwara was born probably in 1440, something like that, and Madhava would have been dead for about 20 years by then.
So, we are not the original works of Madhava. Most of the original works of Madhava are not available with us. We are learning from other books written by his
Shishyas and their Shishyas, Shishya Parampara, and I think they are very reliable, because by then, the records are reasonably good, and especially what Nilakantha says about Madhava, I don't think we should question, because he is obviously very full of the Madhava lore, which he has got from his grand guru Parameshwara. So, I think we can trust that. And about the dates, Parameshwara was probably not. Parameshwara is the only disciple of Madhava that we know of. If there were others, we don't know. But Nilakantha says in several places that here is a verse due to Madhava, or Shankaravarya will quote 2 or 3 verses, or Yashtadeva will quote 2 or 3 verses with no attribution. It doesn't say it is from Bhaskaracharya, and when we cannot attribute them to other people, it is customary, at least most scholars do it now, they think these are verses, occasional verses written by Madhava. We do not know a collected book in which he has put it all together. I don't think he did that. My personal view is that he never got around to writing. I think he was an extraordinarily brilliant mathematician. He had no time to write books.
That's a very correct.
Yeah, I think so.
Many people are like that.
Yeah, I think so.
And regarding Madhava's contributions, one main thing is usually considered as the Grigori series. That Vyase, Vairudya, that's
yeah. No, actually, this has been known for a long time. That is to say, these verses due to, for example, at the time when Ramavarman Thamburan and Akhileshwar Iyer produced their book, they were in touch with a professor of mathematics in Madras at that time, C.T. Rajagopal, who did a great deal by writing articles, publicize these things. So, those who read that, and that was published in English, those who read that knew that several of the series which we know by other names now, like Gregory series or Leibniz series or Newton series for the sine and the cosine, they were all done by Madhava, and more than that, they were done in a way which was quite dazzlingly original to these people. But C.T. Rajagopal also did not read Malayalam. Okay. He depended to some extent on someone who, Balagangadharan, who was in the Tata Institute School of Mathematics for a short time.
He was in our department also for some time.
For a while. He was in your department for a while. And he was an old friend of mine. I knew him very well. So he produced the first collected bibliography of works of Kerala origin at that time, during the time of Madhava to let's say Achyuta Pisharadi. So, so in that sense, that was known early. So everybody thought, wonderful, he's anticipated Gregory and Leibniz and Newton by 275 years, but they thought that was all. But if you read Yuktipasha now, and if you read it carefully, and you follow all the little detailed steps one by one, then what you see is that it is not that these series were produced by Madhava. He actually invented calculus, because the series, especially the so-called Gregory series, that is the series for pi.
Not only stated it,
the
proof is also given.
Proofs are complete and in many ways much better than the proofs in Europe, which came much later. It's very detailed, the proofs are very detailed, formally very satisfactory, intuitively very clear what the driving force is. And if you analyze this, it's very clear that what he has done was to invent infinitesimal calculus, but for only trigonometric functions,
sir,
not for general functions.
Sir, why these people are interested in evaluation of the...
Oh, that's a very interesting, but unfortunately it's a very complicated question. It's also a technical question. Because for this we have to
related to astronomy?
It is indirectly related to astronomy, but I will have something to remind me to talk about the non-astronomical aspects of the work of I call this school the Nila school, because the Nila Nadi is the river which nourished all these villages. These are all these famous 64 villages which were set up by supposedly by Parameshwara, Panniyur, Shogapuram, Tirunavaya, all these places. So I call it the Nila school because all these people lived within 10 kilometers of one another. From Trikandiyur to Kodallur is not very far, 15 kilometers. So, so given this thing, I call it the Nila school. So the Nila school's work for me is characterized by great originality, and for the first time to take mathematics away from its astronomical applications. But I'll come to that maybe later if there is time. But the original starting point is Aryabhatta, and Aryabhatta's mathematics was fully driven by astronomy, because he took the astronomical model from Alexandria, supplied the mathematics which was already developed in India, added to his own invention, such as, for example, trigonometry. So that's the reason why all these people were looking at trigonometric functions. So what he did was then to prepare a famous table called the sine table, in which for a certain set of values of an angle in a circle, he computed what we call the sine function. Now there is a very mysterious, very difficult to read, very elliptic verse of Aryabhatta which says, we can do this for arcs of the circle, that is angles, which we can fix according to our wish, yatheshtani. Okay. In other words, arbitrarily. As modern language, modern mathematical language will say, for arbitrary angles, I want to compute the sine. Okay. Now, of course, he only computed it for steps of pi divided by 48. That is, the circle is divided into 96 equal parts.
He is also giving an approximate value for pi in Aryabhatta.
Yeah, because you cannot do this without a value.
3.1416.
Yeah, there is a value. Aryabhatta gave a value for pi. Not only did he give a value for pi, he also said it is proximate, not approximate. It's very close to it, the correct value, but it is not the correct value. So then, so if he says that you can do it for arbitrary angles, somebody has to do it. For 900 years, nobody did it, because many people misunderstood what Aryabhatta meant. Like, for example, the first Bhaskara, not the Bhaskaracharya that we know famously. Even the Bhaskaracharya, in his actual work, he also says that you can make it small, but he never used small angle values for the trigonometric functions. It is non-trivial to do it, because the big change is that you can make them, you can cut them into smaller and smaller pieces, and you can determine the function sign for each such piece. But Madhava's great genius lay in the fact that he said, I don't want to cut it into pieces. I want to do it for arbitrary values of the angle, not arbitrary divisions of the circle, but arbitrary but equal divisions of the circle, but arbitrary angles given any value of theta. It doesn't have to be of the form 2 pi divided by n multiplied by some number. any value whatsoever. I want to know what the sine function is. To know that, since you are going to look for exact values of the sine, you want an exact value for pi. That is why he developed what is now called Gregory series, the value of pi. And that is in fact the derivation of that infinite series for pi is probably the most revolutionary step taken in Indian mathematics. I personally, it's a very, very powerful result.
A series is evaluated.
It's not just, first of all, to imagine that you can write an infinite series and give it mathematical sense. We don't know that it makes mathematical sense. I mean, in fact, it's the first time that it was done. Number one. Number two, to realize that you cannot give a value for pi in the form of, let's say, a rational expression, okay, numerical expression divided by some fraction, sums of fractions, whatever. You cannot give a value for the angle theta as a rational function of tan theta. All of that is implicit in this. Then, to actually say, all right, I can't do all those things, what can I do? I can write an infinite series and I can prove that it is exactly correct. So I think Madhava's greatness is no longer in question. For a long time, no one knew. You know, the amazing thing is that we have satellites named after Aryabhata. We have
in fact, satellite is named as Aryabhatta, not as Aryabhata.
Well, that's a complicated question. We don't want to get into it. It's Aryabhatta. They don't. You see, if you drop the last vocal Aryabhatta, you say it Aryabhat, then you lose information about whether the last T is a T or a double T. And Bhatta, people were very fond of using it.
And in all the textbooks, whenever Aryabhata's name is mentioned, either by him or other people, it is always written as Aryabhata, not as Aryabhatta.
No, if you write it as Aryabhatta, then the verses won't scan, because Bhatta is Laghu Laghu, Bhatta is Guru Laghu. So it won't scan. So that is no one doubts that.
This people of this school considered the Gregory series expansion for pi as well as some other series which can be used to evaluate the value of pi.
Yeah.
But are they interested in the convergence of a series of an arbitrary series?
You are asking very technical questions, but I will answer.
For example, in I read that in this Aryabhatiya Bhashya of Nilakanta, some other series are also evaluated. For example, the geometric series.
You know, geometric series is a very elementary thing, you know, in the sense that the reason why he used it for two reasons. One is the geometric series comes in the evaluation of the series for pi, okay, because it comes as 1 over 1 plus t square. Secant square theta, you want to expand it in powers of tan theta. So you get 1 over 1 plus t square. So its Indian version requires exactly the same expansion. That's one reason. The other is the geometric series, for proper choice of the variable, is the most elementary example of a convergent infinite series. So Nilakanta used this series to illustrate the idea of what is meant by the sum of a convergent infinite series. In particular, he says at one point, it must attain but not overshoot the value. So it is a limit. It is to be understood as a limit. So for that reason, he actually used the I think 1 over 1 minus 1 quarter or something like that as an example, as an illustration of
1 plus 1 by 4 plus 1 by 4 square, etc.
Yeah, exactly. So that's what he did. So there were many such signposts to a very modern way of thinking. Not only that, there is so as I said, it's a very technical question. The tangent series, that is theta is t 1 minus 1 over t plus 1 over t cubed, 1 plus 1 over t cubed and so on, that converges only between 0 and pi by 4. At pi by 4, tangent theta is 1. Beyond pi by 4, it's greater than 1. So this series won't converge. It's on the edge of being convergent, because you know it's a conditionally convergent series. It's not absolutely convergent. If you change the minus signs to plus signs, series doesn't converge. So it's a borderline case. So Yesterdeva says, all right, so what do we do when the angle is bigger than pi by 4? He said, then you must make sure that instead of expanding in sin theta divided by cosine theta, which is always less than 1, you must now expand everything in terms of cosine theta divided by sin theta, which is less than 1 for angle between pi by 4 and pi by 2. This is very, very clearly explained. So they were concerned with questions of convergence. They did not have, naturally, they did not have very sophisticated ideas of what is convergent, what is conditionally convergent. Those things are not there.
Power series for this sin x and cos x.
That was the goal, no? That was the holy grail. You wanted a power series for sine, and to get there, to make sense of it, you have to make power series for tan theta or pi. There the derivations are technically extremely complicated, very tricky, but in the light of what we learn in school calculus or college calculus, they can be streamlined into something also very, very original and very modern. Very original, very modern. But there are some ways in which this work differs from what we call calculus. Now, because we know calculus as developed by Newton and Leibniz, and they do it in a certain way. They get lost in what is meant by an infinitesimal. Such confusions are not there.
In an article, you are calling Yuktibhasha the first textbook of calculus.
In one article, yeah, my very early article.
Is it a bit exaggeration claim?
Other people have asked me the same question, so I'm not.
When I read, I felt that it is a bit.
That's because you're a modern mathematician. You've been trained in the modern way of doing things. The reason why we think it is probably not calculus, is that when we learn calculus in college, we learn about general functions. What is meant by a function, what is meant by a small change in the independent variable, how does it change the function itself, and then we go from there. Okay. Here you won't find any treatment of the general function. You will only find sin theta, cosine theta, theta as a function of tangent theta, and things like that. So, my answer to this is, in Yuktibhasha, there are derivations of the surface area and volume of a sphere. And this is not found in any other Nila textbook, nowhere else. Now, if you go through this and convert all the sentences into symbols and equations, you write it all down, what you get is what you learned in college and what I learned in college. Exactly, you take the sphere, divide it into a series of infinitely thin strips by latitudes, compute the area of the strip, pretending that there is no curvature, because you're going to take the limit in which the width is going to 0. Then add them up and take the limit at the end. That's exactly how I learned in college, and I think that's exactly how it is in the textbooks now. And the Yuktibhasha proof is precisely that. So the point is not so much that they didn't work with general functions. The idea of a general function was just about crystallizing at that time. There are places where you can see the first signs of it, but generally speaking, they didn't have that. So they did it for all the functions they needed. It's like this: Newton and Leibniz did it for functions they knew. They did not prove the fundamental theorem of calculus was stated for one variable. It was not stated, as people state now, in the differential geometry context as Stokes' theorem. That is, you take an n form, integrate it over on an n-dimensional manifold, take an n form, integrate it over the volume, and you get the n-1 form integrated over the surface. That if you say that to Newton, he wouldn't understand what you're saying. Or theory of distributions. Okay, a calculus is applicable to the theory of distributions.
Most of the modern mathematicians are interested in stating everything in the most general form.
No, that's natural. I think that is the greatness of mathematics. They extend their horizons at every turn. But to say that what Madhava did is not calculus is like saying somebody who is working on, let's say, distribution theory, saying that what Newton did was not calculus. The same fundamental ideas, they are extended, as you say, more and more to bigger and bigger areas of domains of mathematics. That's the way I look at it. It's my view. Everybody will not agree with me.
I really enjoyed this discussion on the work of Kerala School of Mathematics. but unfortunately due to some time constraints, we have to stop this episode, and we'll continue this discussion in the next episode.
Yeah, we can carry on.